At the start we had to do quite a lot of ground investigation work. We had to investigate what type of soils we've got across the Broads, and a lot of them are quite peaty and sandy clay soils, which aren't particularly very good for doing flood defence earth embankments. So we did this large-scale investigation. We built up a great big database, and we worked out which are the best soils to use, and we used those parameters to design our flood defence. Traditionally, you would just build a wall, maybe either a brick wall or an earth embankment. In some cases, we have done that, but we've increased sort of the standard of protection by doing what's called setback banks or rollback banks. I'll just explain. The setback one, we actually physically move flood bank back sort of 20, 30 metres. You increase the flood plain. That does have its problems though, because you are building on virgin ground then, you're not building on ground that's already been pre-consolidated. But you just manage it then. If you have built a new setback bank, then you have that maintenance programme to go back and top it up if it's settled too much, to maintain that design level. A lot of the problems we had were due down to stability, and because we had the peaty sandy clay, it's not good on stability. So once we got our database set up and our parameters, we could work out the minimum distance between the soak dike and the flood bank to aid stability. If we were building on the peat soils, what tended to happen was once you loaded that original bank, it slipped and slid into the soak dike. So to prevent that happening, we needed to ensure our soak dike was at least 10 metres away from the flood bank. So that's why you'll now see the soak dikes or the drains away from the flood bank. Originally they were quite close, and that's where the problems arose.
The banks have been strengthened, so you can see the nice wide crests, the slopes, the front slope and the landward slope generally are sort of a 1 in 3. So when if the water does come up, it sort of spills off gently. We also have some areas that we design as overtopping areas, so that if the water levels do get too high, these areas preferentially overtop, and they have a much sort of slackened slope, so they tend to be more of a 1 in 5, and sometimes they have some special protection on the rear so that they don't get all eroded and scoured as the water sort of eddies over the top.
Okay, so the rollback bank, what we tended to do, most of them had dilapidated piles in front of the river edge there. So we pushed the piles in with one machine, and then that was followed by another excavator that reprofiled the front of the bank, and then from that we reprofiled the whole bank building on top of the original bank to strengthen the flood defence. And we let the front edge reed up, creating a more natural environment for things like waterfalls and otters. On Broadland Water at Great Yarmouth, there's a stretch of the flood bank that's right next to Network Rail's property, and we only had about a 10-metre footprint to do works on the flood defence there. So to keep the same footprint, what we used was these open soil baskets. So you lay the basket down, you fill it part way up with soil that we reclaimed locally, and then you fold the basket over, and then you build the next layer up. So that increases the strength of the flood bank, and it also provided a resistant front face for when you got a flood event. So the Broadland Water's tidal, so you've got those tidal surges. So the baskets at the front, once they're vegetated up, they provide a good barrier for erosion. And then we're protecting the railway at the same time.
We've achieved 240 kilometres of resilient flood banks. We've applied various techniques to achieve that. So we've either strengthened an existing bank when we had sufficient depth between the river and the toe of the bank, or we've used a sort of a rollback technique where we sort of moved the new bank just slightly behind the existing bank and then sort of taken that down. Or in some cases we've moved the bank 20 metres or so inland. That's what we refer to as a setback bank. We often do things like that where the old system had some old steel sheet piles. They're a bit of a liability to have. Obviously steel is expensive, you have to replace it relatively regularly, whereas if you encourage reed beds to grow, they provide a natural erosion protection system, so we sort of encourage that to happen. So we've sort of taken quite a sustainable approach to how we sort of manage the banks here. First choice really is to use nature. So the reed beds, they grow all around us here, so they offer great protection. But sometimes that's not always possible. Either maybe they don't take so well, or the rund is a bit too high, or there might be kind of a lot of boat traffic and they just don't establish for some reason. So we have other options. We can use sort of rock gabions, so they tend to be sort of metal baskets that we sort of put rocks in, and they just hold the riverbank together. We also have sort of matting that we use, so we can sort of drape that. That's often used when we've just had to do some work. So maybe if we've taken some piles away and we've re-landscaped the river edge, obviously that's just bare earth. So we would lay the matting down, and that helps hold everything together while the reed establishes itself. We've used quite a lot on this project. We've kind of tested out various options. We've used reed kind of bundles, all sorts of wooden timber piles, plastic piles. There's all sorts of techniques.
So over the course of many years, various people had put in piling. Some of it was for flood defence, so it was to raise the land and give a natural barrier for the water. But the best approach was to remove that piling and give the banks a much more natural profile, and to have a reeded edge running down to hold the material in place. A natural bank looks much more attractive. It has habitat benefits, and it also removes sort of some of the expense of maintenance over the long term. So steel piling, very sharp edges, very intrusive to the eye, and also not conducive to habitat. So having that removed and having the natural edge has really brought benefit to not just the aesthetic, but actually the creatures who live within the park.